Welcome back. We're now on lesson 7, dimensional analysis. This is, well, sig figs, it informs everything in chemistry, but dimensional analysis is the math of nearly everything in chemistry. So it's really crucial that you learn this skill. It got me through chemistry, it got me through physics. Being able to solve problems by just looking at the units is a game changer. So dimensional analysis. Much of chemistry requires converting between units, such as converting from inches to feet, seconds to minutes, meters to miles, etc. In order to convert from one unit to another, we use a method called dimensional analysis, using the dimensions, using the units. In dimensional analysis, we need a conversion factor, which defines the relationship between those two units, usually expressed as a fraction. For example, to convert between seconds and minutes, the conversion factor would be the definition that relates them, or 60 seconds is equal to 1 minute. The conversion factor defines the relationship between seconds and minutes. We express it as a fraction. It's either 60 seconds over 1 minute or 1 minute over 60 seconds. And I'll show you how to know which one to use. But notice that each of these conversion factors essentially equals 1 because the numerator is equal to the denominator. So we can multiply by conversion factors ad infinitum because we're essentially just multiplying by 1. Here's the general template for solving dimensional analysis problems. We determine what unit we want the answer in. We identify what's given in the problem. We determine the conversion factor. We set up the conversion factor in such a way that the units of the given cancel out and we're left with the units we're solving for. And then to solve, we multiply the numerators together and divide by the denominators. Now, I'm fully aware, and I tell my students this every year, I am fully aware that a lot of these problems you can solve without this method. Trust me, this is not about solving the problem. It's about learning the method. So bear with me. It may seem like a lot more work, but it will save you. Okay. So I always set up the problem. Question mark wanted equals given dot line. So we want to know how many minutes is 12 seconds. So how many minutes equals 12 seconds? And I say dot line because that's where my conversion factor is going to go. I need a conversion factor that is going to cancel out seconds. So I'm going to need a conversion factor that has seconds in the denominator and a conversion factor that's going to give me what I'm looking for in the numerator. What relationship do I know between seconds and minutes? Well, I know that there are 60 seconds in 1 minute, right? I cancel out the units that are in the numerator and denominator, and I'm left behind with minutes. The last step I need to do is actually do the math. So I have to multiply the numerators together. So that's going to be, and I do this in one, I'm just being explicit here, but I do this in one fell swoop in my calculator, 12 times 1 divided by 60. So bear with me as I get my calculator here. Okay, so 12 times 1, which is 12 divided by 60, tells me that this is 0.2 minutes. Do I have any digits that would tell me that I need more sig figs here? How many sig figs is my given in? My given is in 2 sig figs. So I want to make sure my answer is in 2 sig figs. And trust me, your calculator doesn't know the least thing about sig figs. So you're going to have to add it yourself, 0.20 minutes. Maybe AI will come and save the day, but for now, use your mind. Okay, so that's the general template for solving a dimensional analysis problem. I want you to practice this for practice problem number 172. Do the problem, pause the video, and I'll be here when you get back. Welcome back. How many kilometers is 2.5 miles? So I write question mark kilometers equals 2.5 miles. And make sure to put an I there because M by itself would just be meters. So I know that I need this unit to cancel out, right? Actually, I'm going to do some fancy color things. Oops, of course, doing my fancy color things, I erased the wrong thing. Okay, so this is miles. And I want my answer to be in kilometers. I'll make that green. Okay, so I'm going to set up my conversion factor first, dot line. I need to first cancel out the units of my given in order to get to miles. So since my given is in the numerator, I'm going to put my units down here, miles. And what's left over is going to be what I want to solve for, which is kilometers. So how many kilometers are in a mile? And they tell us here that 1 mile is equal to 1.61 kilometers. Notice I didn't worry myself about whether the number goes on top or bottom. The units led me. They told me where to put the numbers. So this becomes a multiplication problem. I multiply the numerators together, 2.5 times 1.61. And I get 4.025. How many sig figs? Remember that definitions don't contribute to sig figs. This is 2 sig figs. So I need my answer in 2 sig figs. So that's 4.025 kilometers in 2 sig figs. I look at 4.0. Does the 2 round up to 0? No. So my answer is 4.0 kilometers. Oops. Let me try it again. Okay. And there will be times when you'll need to use more than one conversion factor to go from the given unit to the wanted unit. Let me show you an example of that. How many feet are in 250 centimeters? You should already be seeing that this is how many sig figs? 2 sig figs, okay? How many feet are in 250 centimeters? I know, actually, let me do my fancy coloring again, just because I can. I know that the very first thing I do, even if I don't know where I'm going, is I want to cancel out centimeters. In fact, let me make my given, or excuse me, my wanted in a different color. So I'm going to cancel out centimeters. That's red. And before I would have replaced the numerator with feet. But I don't know the relationship between centimeters and feet. I only know the relationship between centimeters and inches. So let me use that. Let me use a different color. So inches, okay? So I know from this definition that 1 inch is equal to 2.54 centimeters. Notice that centimeters cancels out. Now I have to do, since inches is not what I'm looking for feet, I have to do another step, a second conversion factor. I'm now at inches, so I need to get rid of inches. It's in the numerator, so I'm putting the conversion factor, the unit inches in the conversion factor in the denominator. And can I go from inches to feet? Yes, right here. So inches to feet. And how many inches are in a foot? There are 12 inches in 1 foot. Notice that inches cancels out 2 and we're left with feet. We're going to multiply the numerators together. So I have 250 times 1 times 1. I'm not going to put that in the calculator, divided by 2.54. And I divide a second time by 12. And I get as my answer 8.202, let's say 8.202 feet. Up to this point, that seemed like a good place to round, but remember, I have 2 sig figs. So I'm looking at 8.2, and I ask myself, does the 0 round up at 2? How about never? And so my answer is 8.2 feet. I want to stress something that I just did in the calculator. Notice I did 250 divided by 2.54, and then I divided by 12. If I didn't divide it by 12, it would have thought that 12 was in the numerator. This is what students often do. This is a mistake they make. They do the difficult chemistry problems, and then they make a mistake in the calculator. So they do 250 times 1 times 1. divided by 2.54 times 12. Notice 12 ends up in the numerator and my answer is wrong. So that lesson was worth everything. Just that one little calculator lesson right there. Okay, so let's go on. Remember earlier when I taught metric conversions, and I think maybe the second lesson, I said that there are two ways to do metric conversions. One is just using the scale, and the other one is using dimensional analysis, which I told you I would teach you at some point, and here we are. Now you're going to learn to convert between metric prefixes using dimensional analysis. To do so, we need to use the scale above to determine our conversion factors. For example, to convert between hectometers and millimeters, the metric scale tells us that 1 hectometer equals 10 to the squared meters, 100 meters, and 1 millimeter equals 10 to the negative 3 or 0.001 meters. To create a conversion factor between the two, we switch the numbers, okay? So if I want to do a conversion factor between hectometer and millimeter, actually, I probably should extend that a little bit. For hectometer, I'm going to use the number attached to millimeter for the numerator. Just trust me here. 10 to the negative 3. Okay, so that goes here. And then for the millimeter part, I'm going to use the prefix here that's provided for the hectometers, which was just 10 squared. So that would be the conversion factor. 10 to the negative 3 hectometers is equal to the 10 to the negative 2, 10 to the positive 2 millimeters. Okay? Let's try a sample problem. Convert 522 meters to millimeters. Notice that meters has no prefix, so our number for our conversion factor is 10 to the 0 power. So we set up our problem. Question mark millimeters is equal to 522 meters. I'm not going to do all the coloring I did before, but I remembered in time to do meters. I want meters to be in the denominator, and I want millimeters to be in the numerator because I want to cancel out meters and replace it with millimeters, okay? I look at my chart. The number in front of millimeters here is 10 to the negative 3. I'm going to attach that number to meters. And the number in front of meters is 10 to the 0. I'm going to attach that to the millimeter half. So to convert from meters to millimeters, I'm going to take 522 and divide by 10 to the negative 3. I'm going to divide by 1 EE negative 3, and I end up with 522,000 or 5.22 times 10 to the positive 5 millimeters. Okay, these meters cancel out. So I want you to try this problem, not try this problem. I want you to do this practice problem number 2 and pause the video and come back when you've solved the problem using dimensional analysis. Okay, I want you to learn the method. It's not just about converting between metric units, it's about using the method. Pause the video and solve this problem. Welcome back. So using dimensional analysis, how many kilograms is 150 grams? I know that I want to cancel out grams and end up with kilograms. I look at my metric table. I'm just going to do some cleaning up here. What were my numbers again? They were kilograms. Kilograms is 10 to the positive 3. I'm going to attach that to grams, 10 to the positive 3. And grams is a base unit, which is going to be 10 to the 0. I'm going to attach that to the kilograms part. 150 grams times 10 to the 0 divided by 10 to the 3rd. So 150 second EE times 10 to the 0 divided by 1 EE 10 to the 3rd gives me 0.15 grams. I know you can solve that without doing this method, but there you go. That's how you would do it. By the way, I just wanted to show you something I did on the calculator. It's how you do scientific notation in a calculator. I always do it 1 times, but this is a really important key to learn, this EE key, okay? So to put in 10 to the 0, I did it like scientific notation in which my significand would be 0. I do 1 second, comma, that's the EE, to the 0 power. That's the same thing. Even I press enter, that's the same thing as 1, right? Divided by 10 to the 3rd is 1 second EE to the 3rd power, and that gives me 0.001. Here are 2 more practice problems. I want you to pause the video, solve these problems, and when you come back, I will show you how I solve them. Welcome back. How many deciliters, DAL, is equal to 0.67 micro is this? I wrote that really big. I wanted to show you what micro looked like, but I really don't need to take all that space. Let me try it again. How many deciliters is 0.67 microliters? It's like a lowercase u or a script u. I want microliters to be in the denominator and deciliters to be in the numerator. I look at my chart for deca. Remember, liters is a base unit. It's a unit for volume. Deca is 10 to the positive 1. So I'm going to attach that number to the opposite side. So 10 to the 1 microliters. And then I'm going to look at micro. Micro is 10 to the negative 6. So I'm going to attach that to the deca, 10 to the negative 6. So it's 0.6. Well, let me actually, before I even put this in the calculator, I just want to show you how to, if you don't already know, how to divide exponentials. So this becomes 0.67. By the way, the microliters cancels out and I'm left with deciliters, right? I have 0.67, and when I divide exponentials, I subtract their exponents. So it's really 10 to the negative 6 minus 1, which is 0.67 times 10 to the negative 7 deciliters. Now, that's not scientific notation, because scientific notation, the decimal has to be after the first non-zero digit. To put this into scientific notation, I would move the digit back 1, making the number larger by 1, which means then I would make this smaller by 1. So in scientific notation, it would be 6.7 times 10 to the negative 8 deciliters. And notice that it has, the sig figs have to agree. I can't just add a 0, because that would imply more precision than I have. Problem number 4. Convert 0.0174 centimeters to nanometers. So how many nanometers is equal to 0.0174 centimeters? I'm going to want to cancel out centimeters, and I'm going to want to end up at nanometers. Let's look at centimeters. Centimeters is 10 to the negative 2. Over time, you're just going to know these by heart. I'm going to switch that or flip it, and then I'm going to put that with nanometers. And nanometers is 10 to the negative 9. So I'm going to put the 10 to the negative 9 on the opposite side with centimeters. So this becomes 0.0174. By the way, the centimeters cancel out. Times 10 to the negative 2 minus a negative 9, which is 0.0174 times 10 to the positive 7, right? Now, this is not an appropriate scientific notation. I need to move the decimal back 2 places to the right, making it larger by 2, which means I need to make this smaller by 2. So my number becomes 1.74, 3 sig figs times 10 to the 5 nanometers. Now, if I wanted to put this in the calculator instead, I do 0.0174 times 1 EE negative 2, not the minus sign, but the negative sign, divided by 1 EE negative 9. And look what I get, 174,000, or 1.74 times 10 to the 5th nanometers. And that's all I have for you for dimensional analysis. This is such an important lesson. Do all the practice you can in dimensional analysis. I have a worksheet for you. Do it again if you need to. Actually, I have 2 worksheets for you. It's that important. Get the practice, get good at this. It will serve you in ways you cannot even imagine. and I'll see you in the next lesson.